In this video, let us see dispersive power of the material of a prism. Dispersive power of the material of a prism shows the ability to produce dispersion. You know the expression for finding the refractive index using a prism. N is equal to sine A plus D by 2 divided by sine A by 2, where A is the angle of the prism and capital D is the angle of minimum deviation. When the angle of the prism is small, deviation produced also will be small. So instead of capital D, we can write a delta. When the angle of the prism is small, we can write for D delta. Then sine A plus delta by 2 divided by sine A by 2. When angle is very small, sine theta will be approximately equal to theta. So now when the angle of the prism is very small, deviation is also small. So this is very small. So instead of sine A plus capital D by 2, we can write A plus delta by 2. Now sine A plus delta by 2 is very small. So we can write A plus delta by 2 for this. Sine A plus delta by 2, we can write A plus delta by 2 because sine theta is approximately equal to theta. So sine A plus delta by 2 will be approximately equal to A plus delta by 2. Similarly, sine A by 2 will be approximately equal to A by 2 when angle of the prism is small. So this A by 2 is very small. So sine A by 2 can be written as A by 2. Then this 2 will get cancelled. Then n is equal to A plus delta by A. A divided by A is 1 plus delta by A. After rearranging, we will get an expression for deviation delta. Take this one this side, so n minus 1. Then delta can be written as n minus 1 into A, where n is the refractive index. Now deviation produced is different for different colors. So we can write violet light we can write delta V is equal to NV minus 1 into A. For red light, delta R is equal to NR minus 1 into A. Refractive index for violet light is more. So deviation produced for violet light is more than the deviation produced for red light. So you subtract delta R from delta V. So delta V minus delta R is equal to NV minus NR into A. This term is called angular separation for two extreme colors, violet and red, delta V minus delta R. It is also known as angular dispersion, delta V minus. So this is the deviation. Delta is the deviation produced for any middle color, green or yellow. Delta is the deviation. So this is for violet light, this is for red light. Delta is the deviation produced for any middle color, green or yellow. Now you divide this by this expression. So delta V minus delta R by delta is equal to this side NV minus NR. You divide by n minus 1. So this A will get cancelled. Now delta V minus delta R. This is the angular separation or angular dispersion. This is the deviation for middle color. Now this is called dispersive power. So dispersive power is defined as the ratio of angular dispersion for two extreme colors to the deviation of the middle color or mean deviation. So this is called dispersive power. It is represented by the letter omega. So dispersive power shows the ability of the material of the prism to cause dispersion. So dispersive power is defined as the ratio of angular dispersion for two extreme colors to the deviation of mean color.